So we're going to talk about topic 2, or unit 2. We're going to kind of split this up into 2 different units. First, we'll do 2.1, 2.2, 2.3, dealing with polynomials, which again we'll define in a second. Then we'll factor. So the first half of the unit is multiplying, adding, subtracting, little operations with polynomials. But then the second half, the orange part now, is all factoring. It's kind of like dividing, but not exactly. So we need to know this vocabulary. Degree of a monomial, degree of a polynomial, difference of two squares, monomial, perfect square trinomial, polynomial, and standard form of a polynomial. So let's keep on cruising. How does adding or subtracting polynomials compared to adding or subtracting integers? So first, why does a constant have a degree of 0? Well, first of all, we need to talk what degree is. A monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. So it's one term, is what they're saying. It could be 6, it could be 7x, many options. The degree of a monomial is the sum of the exponents of the variables. So the degree for 6 is 0 because there's no variables. For 7x, there's 1. If we did something like that, it's a monomial still, it's only one term. But now we have a degree of 3 because we have 2 x's and 1 y. So degree of a monomial is the sum of the exponents of the variables of a monomial. So it's the highest degree of a polynomial. The variable has an exponent of 2, so it's degree 2. Whereas this one, the sum of the variable exponents is 7. 5 x's and 2 y's. It doesn't matter if they're the same variable, you just have to add up all the variables. A constant has no variable, like we saw here. So it's kind of like saying x to the 0. And hopefully we know, or remember, that anything to the 0 power is 1. Do that. Star to the 0 is 1. Up John to the 0 is 1. Doesn't matter. So they kind of take you through and see why it is what it is. So 7 times x to the 0 is the same thing as 7. 7, or x to the 0 is 1. 1 times the 7 is 7. So we started with 7, we ended with 7, so x to the 0 really doesn't do anything. But that's why the degree of a constant is 0 all the time. So just a regular integer, a regular number with no variables on it, the degree is 0. Now, we're talking a little bit more. Polynomials. A polynomial is a monomial or the sum of difference of 2 or more polynomials called terms. So again, what that stands for, poly means many, nomial means term. So we're talking about many. So many terms. That's what a polynomial is. So the degree of the polynomial is the greatest degree of any term in the polynomial. So 7, again, has no exponent, has no variable, so our degree is 0. And we can name them based on the degree. If we have a degree of 0, it's a constant, because it's always going to be 7. If we have 4x, that's really 4x to the first. And since we have one variable, the degree is 1, and it's called linear. You guys did that last year when you were graphing lines. The next one, 3x squared plus 2x plus 1. Well, the highest degree is 2. So our degree is 2, and that's a quadratic. This is what we're going to focus on really most of this unit. Negative 5x squared y, I got 1y, 2 x's, grand total of 3 variables, and 3 variables makes it a cubic. 4x squared y squared plus 5x minus 2y plus 6, the biggest one, or the biggest degree is that one. We have 2 x's, 2 y's for a grand total of 4 exponents, so 4 degree. And anything 4 and more, kind of what this thing before I got cut off, is just going to be 4th, 5th, 6th, and so on. They don't have special names for them, just the first 4. We can also name polynomials by the number of terms they have. So we're using, well, no, we're not using quite the same problems, but so 4x is just one term, so it's monomial. Again, mono means 1, bi means 2, and tri means 3. So if we have 2 terms, it's called a binomial, because bi means 2. Negative 5x squared y plus x squared plus x, we have 3 terms, so it's a trinomial. We're going to be facing, probably more often than not, are the trinomials, and binomials maybe a little bit. The last one, the highest degree, is from the 4x squared y squared, so as degree, or number, actually we don't care about the degree, sorry. Polynomials, we have 4 terms, so it's just called a polynomial. 5, 6, 7 terms, they're all just called polynomials. Doesn't matter how many terms there are after 4. So if we're looking at 5x cubed, or minus 4, well, we can name it 2 different ways. First, it's got 2 terms. So it's a binomial. Second, the degree of the whole polynomial is, we're looking at that 5x cubed. The highest degree is 3, so it is cubic. So it has it here, cubic binomial. Name each polynomial based on its degree and number. Again, there's 1 term, so it's a monomial. And the biggest degree is 3. We have 1x, 2 y's, together that's 3, so it is cubic. Cubic monomial. Next one, 6xy minus 3x plus y. Biggest degree is a 6xy, or 6x to the first, y to the first. So that's 2. So it's a quadratic. And it has 3 terms. So it's a trinomial. Now another thing we can do with polynomials is write them in standard form. Whoop. Sorry, I don't know what happened there. It kind of went away for a little bit. Where were we? There we are. Again, standard form of polynomial is when our degrees are written descending order. So biggest degree on the left, and then smallest degree as we go to the right. So they have the example here, 7x minus 5 minus x cubed plus 6x fourth minus 3x squared. So what is the biggest degree? 4. Then x cubed and negative 3x squared, and 7x, and of course the constant has no degree, so it's last. And it's just telling us what order to put them in. 6x to the fourth goes first, minus x cubed goes second, negative 3x squared goes third, 7x goes fourth, and negative 5 goes last. And that's probably the order we're going to write them in anyways. We just like to see bigger exponents to the left and numbers to the right. So that's what that's doing. This is standard form. Just putting it in order. So these are not super difficult. Here, we have a degree of 3, 2, and 0. So the 3 degree goes first, 3x cubed. Then the 2 degree, plus 6x squared. And then our constant with our 0 degree, plus 7. Similarly, letter B, we have a degree of 1, 0, and 2. So the 2 goes first. Remember to bring the negative with it. Then 2y, and then minus 3. That's in standard form, just reordering it. Nothing too crazy. All right, combine like terms and write each expression in standard form. So we just have to add like terms. So if they have the same variable and the same number of that variable, they're like terms. So we do have some like terms here. 4x squared, and negative x squared. And remember, that's a negative 1x squared. So 4 plus a negative 1 is 3, and that's our x squareds. And then we have negative 3x and positive 3x. Well, they cancel out. So the only thing we have left is 3x squared. Letter B, same type of thing. See, we got a 7y cubed, we got a 5y cubed, or 12y cubed. Then we have our negative 3y and our negative 2y, negative 5y. Notice we don't have a quadratic term. And then lastly, a plus 7 at the end. So that is, in standard form, the sum of those terms. Add polynomials. So it's just like adding regular numbers, where you line up the right places and you add down. So over here we have 3 plus 5 is 8. 2 plus 0 is 2, and 1 plus 4 is 5. So 123 plus 405 is 528. Well, that's the same thing with our polynomials. We're adding x squared plus 2x plus 3, and we're adding that to 4x squared plus 5. So 5 lines up with the 3. The 4x squared lines up with the x squared, and there are no other x terms in that second polynomial. So you just leave it blank. Or you can put 0 if you want to just kind of make sure that we're not missing anything. So 0x. Of course, 3 plus 5 is 8. 2x plus 0x is still just 2x because we're adding nothing. And 1x squared plus 4x squared is a 5x squared. This is what we get when we add terms. We got some more here. There's several methods. One is vertically, where we line them up. Negative 3 plus 6 is 3. 2x, and there's no other x term in the second polynomial. And the first one is 4 plus 3, so 7x squared. So number 4, A, well, there's no x squared. Let me take that back. There's no x squareds in the second polynomial. We can add then 2x and negative 1x, so positive 1x. And then we have the 9 by itself. So we only had 2 like terms. That's fine. Again, it's in standard form. We have our x squared, our x, then our 9. So here it's the same as well. There's only the one x squared term. We have 5x and 3x to give us 8x. And negative 7 and positive 7, well, they cancel out. So we just have this. Again, it's a descending degree. Negative 2x squared is 2. 8x is 1. It's 2 terms, so it's a binomial. And quadratic because our degree is 2. Now, subtracting polynomials is basically the same thing. So you can line them up and then just subtract. I think that's a little bit more difficult. What they have, and it's kind of cut off, is distribute negative 1 to each term on the second polynomial. So it'll be 6x squared plus 3x minus 2. That doesn't change. But now we're subtracting 3x squared. So it's like adding a negative 3x squared. We're subtracting 5x. So it's like adding a negative 5x. And we're subtracting 8, so that's like adding 8. And then we just add down. So we have 3x squared minus 2x plus 6. They grouped them up here, which is fine. It's just an extra step that we don't really need. So just add your like terms after you distribute the negative, and we're good. So the difference of those two polynomials, 6x squared plus 3x minus 2, and 3x squared plus 5x minus 8, is 3x squared minus 2x plus 6. All right, we got 2 more problems here. So we have 3x squared. First, let's distribute the negative. Not the positive x and a negative 4. So there's only one x squared. Now our x terms. We got 4x plus a positive x now. So that would be 5x. And 2 plus 4 is 6. It's in standard order or standard form. And we have no more like terms to combine. Again, we'll distribute the negative. So it's going to make the negative 4x squared negative and the 6 negative. So there's only one x squared term, the negative. Bring the negative with it. Negative 5x And then we have negative 6 minus 6, so negative 12. And nothing too crazy, not anything that you can't do. Now, an engineer is reviewing the layout of a solar farm. The solar farm shown has 4 small panels, 33 medium panels, and 32 large panels. What is the total area of the farm's solar panels? Well, the area of it is, see if I can get it to look something like it really is. So the area of the solar panels is this whole thing. But they want to find the area of that whole thing. So we're going to add 32x squared and 384x. We're going to add to it 4x squared plus 24x. And then the medium ones are 33x squared plus 272x. So we add those up. 32 plus 4 is 36, plus 33 is 69x squared. 384 plus 24 plus 272 is 680, and that is our x term, and that's it. There's no constant, there's no cubic terms. That's all we got. The total area of the solar panels is modeled by the expression 69x squared plus 680x, just like we saw. And then this is what we actually did in class, a very short form of what we just looked at. So standard form, again, is in descending order according to degree. So 4, 3, 2, oops, that's not right. 4, 2, 1, 0. And again, like we saw, they can be named according to the number of terms and the degree. Number of terms, we have 1 term, it's a monomial, 2 terms, binomial, 3 term, trinomial, and 4 and up is a polynomial. Degrees, 1 is linear, 2 is quadratic, 3 is cubic, and again, 4 and plus is just 4th, 5th, 6th degree, so nothing fancy. So really, you gotta memorize these 6 things. We have some more adding polynomials and subtracting polynomials. So I circled the similar monomials. Negative 2x squared and 4x cubed, or sorry, negative 2x cubed plus 4x cubed. When we add, we get a, looking over there, we get a 2x cubed. That's what's here in the red. When we add up our 4x squared and 2x squared, we get 6x squared, just 4 plus 2. There's only one x term, that green term, so it's just minus x. And then we got negative 5 plus 8, which is just 3. So this is our final answer. Subtracting, same type of thing. You distribute the negative first, and then you just combine your like terms. 3x squared and 3x squared is 6x squared. Negative 2x and plus 1x is a negative 1x. And 4 plus a negative 6 is a negative 2. This, again, just adding like terms. We talked about the degree of constants. So again, if that was 3x to the 0, because that's a degree of 0, we know that anything to the 0 is 1. 3 times 1 is 3. So 3 has a degree of 0. And so to 7, 8, negative 5, 3 billion, negative 400 trillion. As long as they're integers and there's no variables, it's a degree of 0.